Welcome to The Explainer. We're just swimming in data every single day, right? From news headlines to product reviews. Today, we're going to pull back the curtain on statistics, the super powerful tool set that helps us sort out what's real from what's just noise.
All right, let's kick things off with a question that sounds super simple. Are basketball players taller than the average person? I mean, your gut just screams, duh, of course. But how would you actually prove that? You see, in statistics, a gut feeling is just the starting point.
Well, if you wanted to be 100% absolutely positively sure, you'd have to line up every single basketball player on the planet and measure them against every single non-player. Yeah, that massive, all-encompassing group, that's what we call the population. And you can probably see the problem here. It's just impossible.
And this right here is where statistics comes in with a brilliant shortcut. Instead of trying to, boil the entire ocean, we just take a small scoop. This much more manageable group is called a sample. And the whole idea, the big idea, is that by really digging into this sample, we can make a really, really good guess about the entire population.
Okay, so we've got our sample. Let's say it's the heights of 100 players. Now what? Well, the very first thing we do is just describe what we're looking at. You can think of it like a detective laying out all the evidence on a table before even thinking about solving the case.
So this first part of the job has a name. It's called descriptive statistics, and its goal is super simple, just to describe and summarize the data you have right in front of you. It's not about making big predictions, it's just telling us what is inside our specific little group.
Okay, so when we're describing our data, the first question is usually, where's the middle? What's the typical value? Where's the center of all this evidence?
And here we see the two most common ways to find that center. First up, you've got the mean. That's the classic average we all learned in school, right? Just add up all the heights and divide. Simple. But then you've got the median. Now this is cool. If you line up all the players from shortest to tallest, the median is just the height of the person standing smack dab in the middle. And that's incredibly useful when you have an outlier, like one super tall player that might throw the average way off.
Right. But just knowing the center, that's only half the story. We also need to know if all the players in our sample are basically the same height, all clustered tightly around that average. Or are their heights kind of all over the map, from really short to extremely tall?
The tool for figuring that out is called the standard deviation. Now, I know, that sounds a little intimidating, but don't let the name fool you. It's really just a single number that tells you how spread out everything is. A small standard deviation, that means our players are all bunched up together around the average height. A big one, that means we've got a wild mix of shorter and much taller players.
Okay, so let's pause for a second. At this point, we have a really clear picture of our sample of 100 players. We know their average height, and we know how much their heights vary. But we still haven't answered our big question about all basketball players, have we?
All right, we've described the evidence. Now, for the magic trick. This next step is where things get really cool. It's about taking that small clue, our sample of 100 players, and using it to make a powerful, educated guess about every basketball player out there.
And this is the second major branch of statistics. It's called inferential statistics. And just like the name says, we are inferring a conclusion. We're taking that leap from what we know about our small sample to make a big statement about the huge population we could never measure.
Now, we can't just guess wildly, right? We have to be scientific about it. So we start by forming a hypothesis. And that's just a fancy way of saying a formal, testable prediction about what we think is true. So for our question, the hypothesis would be something like, basketball players are on average taller than the general population. And the process for doing this is super logical. Step 1, you state your hypothesis. That's your prediction. Step 2, you use your sample data and some specialized statistical tests to see if the evidence actually backs up that prediction. And finally, step 3, based on that test, you draw a conclusion about the entire population.
So how do we actually test it? Well, we use these powerful tools, like the one you see here, the t-test. A t-test does something pretty amazing. It helps us figure out if the height difference we saw in our sample is a real thing, or if maybe we just got lucky and happened to pick a randomly tall group. If the test tells us the difference is probably real, we get to call the result statistically significant. That's the gold star.
Okay, so let's put it all together. Think of it like this. Descriptive statistics answers the question, what does our evidence say? It just summarizes your sample. But inferential statistics asks a bigger question. What does our evidence mean? It tests your predictions to make a statement about the whole world. So one describes, the other concludes. Simple as that.
And that, right there, is the fundamental power of statistics. It's not just about numbers. It's a whole framework for thinking critically about evidence and about being uncertain. So the next time you see a headline that says, "A new study finds," or an ad claiming 4 out of 5 dentists recommend, hopefully you'll have the tools to look a little deeper, to ask, okay, what's the evidence, and what does it really mean? Thanks for tuning into The Explainer.